Look up at the night sky. For millennia, we saw only points of light, stars, planets, the occasional wandering comet. But today, that darkness is filled with our own creations, tiny artificial stars that we call satellites. These machines are our eyes, our ears, and our messengers, silently circling our world. The ability to place these tools in the heavens has become a measure of a nation's power and ambition. On October 11, 2025, a new and powerful player made a bold move in this cosmic arena. From a floating platform in the Yellow Sea, a pillar of fire and smoke announced the launch of China's Gravity-1 rocket, a vehicle that is changing the rules of the game. This was not just another rocket launch, it was a statement. The Gravity-1 is the most powerful solid-fuel rocket ever built, a titan born from a young private company called Orienspace. Its successful journey to orbit was a demonstration of incredible engineering and a signal to the world that the landscape of space exploration and security is shifting once again. The story of this rocket is about more than just metal, fuel, and fire. It is a story about human ingenuity, national pride, and the ever-expanding frontier of technology that now reaches far beyond our atmosphere. It challenges our ideas about who leads the journey into space and how that journey will shape our future. Imagine a highway into the sky, one that is cheaper, faster, and more reliable than ever before. This is what the Gravity-1 represents. For decades, launching anything into space was an expensive and time-consuming endeavor, reserved for the wealthiest governments and largest corporations. But what if you could launch a satellite as easily as ordering a package? This new rocket brings that possibility closer to reality. It opens the door for deploying vast networks of satellites, constellations of hundreds or even thousands of machines working together for communication, observation, and defense. List chunking, media group, satellite dishes under open sky for communication, outdoor telescopes observing sky for observation, stop and distribute equally for communication, observation, and defense. This single event off the coast of China is a ripple that will create waves across the globe. The launch also tells a deeper story about the changing nature of human enterprise. Orienspace, the company behind this marvel, is not an old government agency. It is a new private venture, founded just a few years ago in 2020. Yet, it has achieved something that has eluded many for decades. This blend of private innovation and state support is creating a powerful new model for technological advancement. As we venture further into the 21st century, the race to the stars is no longer just between superpowers. It is a complex dance of commerce, competition, and collaboration. And the Gravity-1 rocket is leading the choreography for this new era. So what is this machine that has captured the world's attention? The Gravity-1 is a true giant, standing 30 meters tall, which is about the height of a 10-story building. But its height is not its most impressive feature. The real power comes from its design. It is what we call a solid-fuel rocket. Think of it like a giant firework. Unlike liquid-fuel rockets, which require complex plumbing and cryogenic fuels that must be kept incredibly cold, a solid-fuel rocket has its propellant packed inside it, ready to go. This makes it simpler, more stable, and much quicker to prepare for launch. The Gravity-1 is a marvel of this technology, a beast of controlled power. Its structure is also unique. The rocket has a central core made of 3 stages stacked on top of each other. But to give it the extra push it needs to escape Earth's gravity, it has 4 powerful boosters strapped to its sides. When the countdown reaches 0, all these engines ignite at once, generating a colossal 600 tons of thrust. That's the force needed to lift its total weight of 405 metric tons off the launch pad. This design, with side boosters, is something no other private Chinese company has ever successfully built. It allows the Gravity-1 to carry very heavy loads into space, making it a true workhorse for the new space economy. The purpose of any rocket, of course, is to carry things, what we call a payload. The Gravity-1 is exceptionally good at this. It can lift a massive 6,500 kilograms, or about 6.5 tons, into what is known as low Earth orbit, or LEO. This is the region of space where the International Space Station and most observation satellites live. To put that into perspective, 6.5 tons is the weight of an adult African elephant. This incredible lifting capacity means that a single Gravity-1 launch can place multiple satellites into orbit at once, or one very large complex satellite. It is a game changer for building out the satellite constellations that are becoming so vital to our modern world. The company that brought this rocket to life, Orienspace, was formed by brilliant minds who previously worked on China's most famous state-run rocket programs, like the Long March series. They took their decades of experience and combined it with the speed and agility of a private startup. This fusion of old-school expertise and new-school ambition is the secret ingredient behind the Gravity-1. They didn't just build a rocket, they built a new way of thinking about space access. They imagined a future where the path to orbit was not a rare and difficult journey, but a routine and reliable service. And with the Gravity-1, they have taken a giant leap toward making that future a reality. A rocket's true test is not its size or power, but its ability to successfully complete its mission. On its second flight in October 2025, the Gravity-1 performed flawlessly. Its task was to deliver 3 new satellites into their precise, predetermined paths around our planet. These were not just random pieces of hardware. Each had a specific and important job to do. One of the satellites was called Jilin-1 Wideband 02B07. This is a high-resolution observation satellite, essentially a powerful camera in space. It was built by another Chinese company, Changguang Satellite Technology, which is creating a huge network of Earth-observing satellites. The Jilin-1 satellite is an incredible piece of technology. It can see objects on the Earth's surface as small as half a meter across, all while flying hundreds of kilometers above us. It also has a very wide field of view, capable of capturing images of a 150-kilometer wide strip of land in a single pass. Satellites like this are vital for everything from monitoring city growth and tracking natural disasters to managing agriculture and observing changes in our climate. They provide us with a god's-eye view of our own planet, giving us information that is impossible to gather from the ground. Each new satellite added to the Jilin-1 constellation makes this global picture clearer and more detailed. The other 2 passengers on this flight were experimental satellites named Shutian Yuxing 01 and 02. These were developed by a company called Orienspace, which is part of the same corporation that makes Geely cars. This shows how space technology is no longer just for space agencies. Even car companies are getting involved. These experimental satellites are designed to test new technologies for communication and navigation. They are pathfinders, exploring new ways to build the satellite networks of tomorrow. Their successful deployment demonstrates that the Gravity-1 can not only carry large payloads, but also handle delicate advanced electronics with precision. Putting these satellites into orbit is more than just a technical achievement. It is about building infrastructure in space. Just as we build roads, bridges and power lines on Earth, we are now building networks of satellites in the sky. These networks are the backbone of our modern information society. They carry our phone calls, broadcast our television shows, provide the GPS data that guides our cars, and give us a constant stream of information about our changing world. The successful mission of the Gravity-1 proves that China has a powerful new tool to rapidly build and expand this crucial cosmic infrastructure, strengthening its position in the global technological landscape. For most of space history, the biggest obstacle to exploring the cosmos wasn't technology, it was money. Launching a satellite has always been extraordinarily expensive, with costs often running into the hundreds of millions of dollars for a single mission. This high price tag limited space access to only the wealthiest nations and organizations. It meant that great ideas for satellites and space missions often remained on the drawing board simply because they were too costly to launch. The dream of a bustling space economy, with thousands of satellites providing a universe of services, was held back by the sheer expense of getting there. The Gravity-1 rocket, and others like it, are changing this economic equation. By using solid fuel, a simpler design, and a streamlined manufacturing process, Orienspace has found a way to significantly lower the cost of each launch. Think of it like the difference between a custom-built luxury car and a mass-produced family sedan. Both will get you where you need to go, but one is far more affordable and accessible. By reducing the cost per kilogram to orbit, the Gravity-1 makes it economically viable to launch not just one satellite, but dozens or even hundreds. This is absolutely critical for building the massive satellite constellations that are now in high demand. Why is this so important? Imagine a global internet service provided from space. To ensure continuous coverage everywhere on Earth, you need a network of thousands of satellites all working together. If each launch costs a fortune, building such a network would be impossible for all but the richest companies. But with a lower-cost launch vehicle like the Gravity-1, the business model suddenly makes sense. This opens up competition and allows more players to enter the market. It accelerates innovation and brings us closer to a world where high-speed internet is available to every person on the planet, no matter how remote their location. This new economic reality has profound military and strategic implications as well. Governments can now afford to build more resilient and capable satellite networks for surveillance, communication, and navigation. If a satellite in a critical military constellation is damaged or destroyed, a low-cost launch system allows for its rapid and affordable replacement. This ability to quickly replenish space assets is a huge advantage. In essence, the Gravity-1 is not just a piece of hardware, it is an economic tool that gives China a competitive edge in a race to control the high ground in space, for both commercial and strategic purposes. In the world of space operations, speed is just as important as cost. Traditionally, preparing a large liquid fuel rocket for launch is a slow and painstaking process. It can take weeks or even months of careful assembly, testing, and fueling before the rocket is finally ready to go. This long lead time is a major limitation, especially in a crisis. Imagine if a critical communication satellite suddenly failed during a natural disaster, or if a military needed immediate surveillance over a rapidly developing conflict zone. Waiting for weeks to launch a replacement is not an option. You need the ability to launch on demand, almost instantly. This is where the design of the Gravity-1 offers a revolutionary advantage. Because it uses solid fuel, the rocket can be manufactured and stored in a near-launch-ready state. There is no need for the complex and time-consuming process of loading cryogenic liquid propellants just before flight. The fuel is already packed inside, stable and secure. According to Orienspace, this allows them to go from a launch order to liftoff in a very short amount of time. In an emergency, they claim a launch could be prepared in as little as 24 hours. This kind of rapid response capability is a complete game changer for space logistics. The choice of a sea-based launch platform further enhances this flexibility. Instead of being tied to a fixed launch pad on land, the Gravity-1 is launched from a mobile ship. This means it can be moved to the optimal location in the ocean to place a satellite into any desired orbit. It also increases safety by conducting the launch far from populated areas. This combination of a quick-to-prepare rocket and a mobile launch site gives China an unprecedented level of responsiveness. They can launch what they want, when they want, and place it exactly where it needs to be in the sky, with very little warning. This rapid launch capability is a powerful strategic tool. In a military context, it allows for the swift deployment of tactical satellites to monitor enemy movements or the rapid replacement of assets that have been disabled by an adversary. It creates a resilient space architecture that is much harder to defeat. If an opponent knows you can replace any satellite they destroy within a day, it changes their strategic calculations. This launch-on-demand model transforms satellites from precious, fragile assets into replenishable tools, giving China a level of flexibility and robustness in its space capabilities that honestly few other nations can match. It can be difficult to grasp just how deeply our modern lives are connected to the silent machines circling above us. These satellites are the invisible threads that weave our global society together. Every time you use your smartphone to find a location, you are communicating with a constellation of GPS satellites. Every international news broadcast you watch is likely beamed down from a communications satellite. The weather forecast that helps you decide whether to carry an umbrella is created using data from a fleet of weather monitoring satellites that constantly watch our planet's atmosphere and oceans. Our dependence on them is almost absolute. These orbiting platforms do more than just make our daily lives more convenient. They are essential tools for science and our understanding of our own planet. Satellites track the melting of polar ice caps, measure the rise in sea levels, and monitor the health of our forests. They give us the hard data we need to confront global challenges like climate change. They look outward too, with telescopes like Hubble and James Webb, showing us the birth of stars and the mysteries of distant galaxies. They are our remote eyes and ears, extending the reach of our senses across the globe and out into the vastness of the cosmos. This is why the ability to launch satellites easily and affordably is so transformative. It allows us to build bigger and better satellite networks. Instead of relying on a few large, expensive satellites, we can now deploy constellations of hundreds or even thousands of smaller, cheaper ones. If one satellite in a large network fails, it's not a catastrophe. Others are already there to take its place. This creates a much more resilient and reliable system. It also allows for new kinds of services, like the promise of truly global, high-speed internet access that can connect schools, hospitals, and businesses in the most remote corners of the world. For nations, having a strong and independent satellite capability is a matter of sovereignty and security. It means they don't have to rely on other countries for critical data, whether it's for guiding their military forces, managing their natural resources, or responding to emergencies. It gives them a seat at the table in global affairs. By developing powerful and efficient launch systems like the Gravity-1, China is ensuring that it can build, maintain, and expand its own space-based infrastructure. It is securing its access to the data and services that have become the lifeblood of a 21st century nation. The quiet, empty vacuum of space is increasingly becoming a domain of military competition. The recent conflict in Ukraine has provided a stark lesson for the world's militaries. The side that controls the flow of information from space has a decisive advantage on the battlefield. Satellite networks like Starlink have been used to provide secure communications for troops, while commercial Earth observation satellites have been used to track troop movements and assess battle damage in near real time. Space is no longer just a place for scientific discovery. It is now considered a critical warfighting domain, just like land, sea, and air. This new reality has sparked a sense of urgency among global powers. The United States, for example, is developing a space-based system to track and counter hypersonic missiles, and there is growing concern about the development of anti-satellite weapons that could disable or destroy an enemy's space assets. In this tense environment, a rocket like the Gravity-1 takes on a new and serious significance. Its ability to quickly and cheaply launch satellites is not just a commercial advantage, it is a profound military one. It allows China to rapidly deploy surveillance satellites to monitor a crisis area or to replace any of its own satellites that might be targeted in a conflict. This capability is part of a much broader modernization of China's military power. In recent years, we have seen a series of remarkable advancements. In September 2025, reports indicated that China had completed its nuclear triad with a new submarine-launched ballistic missile. Around the same time, it unveiled advanced anti-ship missiles and new drone-killing technologies. The development of the Gravity-1 is not happening in isolation. It is a key piece of a larger strategic puzzle, providing the space-based support system, the eyes, ears, and nervous system, for these advanced terrestrial weapons. It gives the Dragon a new and powerful set of teeth in the sky. Western military analysts are watching these developments with growing concern. The ability to launch satellites on short notice disrupts the old balance of power. It creates a space infrastructure that is highly resilient and almost impossible to completely dismantle. While China maintains that its space program is for peaceful purposes, the dual-use nature of this technology is undeniable. A rocket that can launch a commercial internet satellite can just as easily launch a military spy satellite. The Gravity-1, therefore, represents a major leap forward in China's potential space warfare capabilities, adding a new and complex dimension to global security. The story of the Gravity-1 rocket is also the story of a powerful and effective partnership. For a long time, China's space program was entirely the domain of the state. Huge government-owned corporations were responsible for designing, building, and launching everything from the Long March rockets to the Shenzhou spacecraft. But in recent years, China has opened its doors to private enterprise, encouraging a new generation of entrepreneurs to enter the space industry. This has unleashed a wave of innovation, speed, and competition that is now bearing spectacular fruit. Orienspace is a perfect example of this new model. The company was founded in 2020, a mere infant in an industry where projects often take decades. However, its founders were not newcomers. They were seasoned veterans from China's state-owned space giants, engineers who had dedicated their careers to working on legendary programs like the Long March rockets. They brought with them a deep well of knowledge and experience. They understood the immense technical challenges of building a reliable rocket. They knew how to manage complex supply chains and how to navigate the rigorous testing and certification processes required for spaceflight. What they combined this state-level expertise with was the spirit of a private startup. Free from the bureaucracy of a large government entity, they were able to move faster, take calculated risks, and attract private investment. In August 2025, just before the second Gravity-1 launch, Orienspace successfully raised a large amount of funding to fuel its ambitious plans, including the development of its next rocket, the even larger Gravity-2. This shows a high level of confidence from investors in this new hybrid model, where the best of the state and private sectors work together. This synergy is a formidable force. The government provides the strategic direction, foundational research, and sometimes crucial infrastructure, like the Haiyang spaceport. The private companies then bring the agility, efficiency, and innovative drive to turn those strategic goals into reality, and to do it faster and cheaper than ever before. This public-private partnership is accelerating the pace of China's technological development across the board, and nowhere is it more evident than in the space sector. The success of the Gravity-1 is a testament to the power of this collaborative approach, creating a system that is greater than the sum of its parts. The launch of the Gravity-1 is more than just a single event. It is a signpost pointing toward the future. We are entering a new space age, one defined not just by exploration and scientific discovery, but by utility and infrastructure. The heavens are becoming a place of commerce, communication, and competition. The ability to access space easily, quickly, and affordably will be one of the defining strategic advantages of the 21st century. China, with the Gravity-1 and its burgeoning private space industry, has firmly established itself as a leading power in this new era. This rapid progress has profound implications for global security. The increasing militarization of space creates new risks and challenges. As more nations develop the ability to rapidly deploy satellites and potentially interfere with the assets of others, the need for international norms and rules of behavior in space becomes more urgent than ever. We must find a way to manage this new domain, to prevent conflicts on Earth from spilling over into orbit. The future of our global communications, navigation, and information systems depends on keeping space a stable and predictable environment for everyone. At the same time, these developments hold immense promise for all of humanity. Cheaper and more frequent access to space will accelerate scientific research, deepen our understanding of the universe, and give us better tools to manage our own planet. It could finally make services like global high-speed internet a reality, erasing the digital divide and connecting every human being to the vast reservoir of knowledge we have accumulated. Orienspace is already working on its next rocket, the Gravity-2, a reusable liquid fuel vehicle with a payload capacity rivaling that of the world's most powerful rockets. The pace of innovation is not slowing down. As we stand here on the shores of the cosmic ocean, we are witnessing the launch of 1,000 new ships. The Gravity-1 is one of the first of a new, more powerful fleet. Its journey reminds us that the quest to reach for the stars is a fundamental part of the human spirit. But it also reminds us that with great power comes great responsibility. How we choose to use this newfound access to space, whether for division and conflict or for unity and progress, will shape the destiny of our species. The cosmos awaits our choice. The story of our future is being written now, in fire and ambition, one launch at a time.